You don't need that. Alright, let's look at Rust programming. So essentially, I have been coding in Rust for a little while now. I've become a developer. Um, I've quit my corporate job to become a developer. And I've been through this Rust language book a couple of times, but I've only gotten like halfway through. So I want to solidify my knowledge in Rust, and how to do that is becoming very proficient. So we're gonna go through the Rust book again. Well, this is gonna be the first time I'm going through the Rust book with you guys, but I like the fact that I can go through the book and do some activities and kind of solidify the previous knowledge and conceptual knowledge that I probably have lost by now. Um, don't look at the beginning where I was having all that issues. I was actually trying to set up this this live for a very long time. So, um, let's get started. Let's like jump in. So I'm gonna read what's like going on, and then we can find activities to do um, within this Rust book. And I think it would just be a fun little series. You know what I mean? Okay, so installation. If you don't know how to install this, this is a really good um, portion. I have this all installed. I feel like you can go through this on your own. Um, this would be for Linux and Mac. I have a Windows. You can use YSL. Um, I don't use YSL. I just I just figured it out. I don't remember exactly how I installed this because it's been so long. It's actually been a couple of years since I installed the Rust up and Cargo and everything like that. But you can go through this. The text editor that I use is actually VS Code. Here, this is actually one of my projects that I've been working on. I've been working on a mempool, Bitcoin mempool tracker, and I'm writing in Rust. So you can see this is one of the structs I'm using to deserialize JSON data, and this is one of my helper functions. So Rust is very useful. I do know a lot of Rust, but there's no harm in going through it again and solidifying foundational concepts. Okay, so you guys are gonna go through this. This talks about editor, blah blah blah. Hello world. Now you've installed Rust. I hope so. I hope you installed it. It's time to write your first Rust program. It's traditional when learning a new language to write a little program that prints hello world into the screen. So actually, I'm going to open up a new window. So that it's kind of fresh. We can also create a new folder. I love to do a Control J to open up the terminal. And I'm just going to put this aside now. We're just going to read this through before we go into VS Code and everything like that. So this is what we're going to do. Project directory setup. So you'll be making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercises and projects in this book, we suggest making a projects directory in your home directory and keeping all your projects there. Open a terminal to enter the following commands to make project directory and a directory for hello world project within projects directory. Okay. This is really good. I don't usually have like a whole directory for all of my projects. I'm actually very lazy, and I just make new folders for new projects, which probably is not as good as it should be. I should be more organized, but that's just my preference. For Linux and Mac, PowerShell on Windows, enter this. So this is actually in VS Code. This is actually a PowerShell terminal. You can see it over here. So it's actually, you just be typing the same commands as you would if you were in Linux or Mac. So it's pretty good. So it says make directory, projects, hello world. I'm pretty sure I can just, this is, oh, okay, they have command line. This is how you do command line. You can, this is your command prompt in Windows. I don't know if you have Windows or Linux, but it's a bit easier if you have that as well. If you have the code editor, that's going to be the same thing as PowerShell. Okay, so I'm going to make this folder. I'm just going to put that to the side. Whoa. Whoa. Okay, I don't think I need anything there. Sorry, this is my like first time. I've never live streamed before. Why is this being difficult? This is not what I want. This is what I want. Okay, so, right. Alright, so, now that we got that sorted, we're going to do a make directory. And let's do, well, it's going to be from root. We're going to do a / projects directory. We're just going to do exactly what it's asking, because the easiest thing to do is exactly what the book is telling you. This is local. This is going to be local on your machine and your computer. There are other ways to save your work, and a big way, a very useful way, is to upload your code onto GitHub. And I'll show you how I upload my code onto GitHub later on when we get more in depth into Rust code and how we're saving our code and making commits. You can also use that for, let's say like you have a really big project, you have multiple developers on there. You can actually upload different, like your code and other people's code into the same project and merge it into your main file. So it's actually really useful. I've used it before on proprietary projects. At this point, I'm not working on a proprietary project, and I'm kind of just trying to freelance my way into doing contracts, smart contracts. And the best way to start is to learn Rust, because Rust is used in a lot of smart contracts, and it's very reliable. I'm going to change directory into my projects folder. You can see that right now it says projects. And then, there I go. Okay, and then it says make directory hello world. So we're making another directory within this directory called hello world. All right. So then we're going to change directory into hello world. All right. Finishing. All right. Is the hello world wrong? I just made it. Okay, let's do like a ls. It says there's nothing in this project folder, so we're gonna do it again. Interesting. Hello world. So I just made it. We're gonna do an ls again. Okay, hello world is there. I don't know what the heck it was saying before. That was weird. Anyway, we're gonna change directory into hello world. See, now you can see that my projects. I'm in my projects directory, and then I'm in my hello world directory after that. All right. What's next? Rust basics. Next, make your new source file and call it main.rs. So we're in this. We're going to open our folder. Picture this is it. We'll just open the folder. Okay, this is our folder. There's literally nothing in it because we haven't made any files. So we're going to create a new file. It's called main.rs. Lovely. Okay, so it says, if you're using more than one word in your file name, use the conventions. They use snake case, not camel case. File name, main.rs, and then we're going to do a function main. Oops. Mine. And this essentially is a print line macro. It prints what you write into it. So hello world. Oops. Did I spell world? One thing that you must remember is your semicolons. It's very important. Okay, so when we save the file, I just do a Control S and go back to your terminal, which right here, I'm just going to pull this up. And so on Linux or Mac OS, enter the following commands to compile and run. So you're going to do rustc main.rs. All right, and then main, and that's going to show us hello world. Usually, I do not use rustc. We use cargo for pretty much everything. We do a cargo build on pretty much everything. And when you're creating, you'll see in the next one, when we go to hello cargo, you'll be creating and using cargo build, cargo test, cargo run. Those are going to be your solid commands for everything. No one really uses rustc unless you're using it at a basic level. And this is obviously very basic because we're just running this hello world. Okay, on Windows. All right. Regardless of your operating system, the string hello world should print, which it did. It printed in our command line. And if you don't see this output, refer back to troubleshooting part installation section for ways to help. Okay. So congrats, you just printed hello world into your terminal. You've officially written a Rust program that makes you a Rust programmer. Welcome, aka Rust Station. The anatomy of the Rust program. So let's review this hello world program in detail. There's the first piece of the puzzle, which is function main. These lines define a function named main, and the main function is special. It is always the first code that runs in every executable Rust program. Here's the first line that declares a function named main that has no parameters and no return, and returns nothing. So usually if you are utilizing parameters, your parameters would be here. You can have multiple parameters, and when you return something, usually you'll put result and then returning parameter 1. Let's just say that this is essentially how you would utilize the parameter and returning result. You could also return something. Let's say that you're trying to return something like parameter 1 instead of putting a semicolon at the end, you just don't put a semicolon at the end. And that will also return that whatever you're trying to return, essentially. All right. Okay. So it has no parameters and returns nothing. If there were parameters, they would go inside the parentheses, as we saw where I put parameter 1 in parameter. The function body is wrapped around in curly braces. So the Rust requires curly braces around all function bodies. It's a good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. If you want to stick to a standard style across projects, you can use an automatic formatter tool called Rust Format to format your code in a particular style. More on Rust Format in Appendix D. So we can go take a look at Appendix D after we're done reading this, because I do want to know a little bit more. The Rust team has included this tool with the standard Rust distribution as rustc is, so it should already be installed on your computer. Okay, let's go down. The body of the main function holds the following code. So that's going to be your print line function that we just created, and that's what returned hello world. So this line does all the work in this little program. It prints text to the screen, where are 3 important details to notice here. First, print line calls a Rust macro. If it had called a function instead, it would be entered as print line without the macro, which is that exclamation point. Rust macros are a way to write code that generates code to extend Rust syntax. We'll discuss them more in detail in chapter 20. For now, you just need to know that using that macro means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. We can go more, I'm pretty sure we're going to go more into detail on the difference between macros and functions, because I am still a little bit confused on how, well, I understand what macros are, but I want more in-depth explanation on what's going on and why they're so different. No. Okay. Second, you see hello world string. So we pass a string as an argument in the printline function or printline macro. A string is printed to the screen. So third, we see the line end with the semicolon, which is really important, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. So that semicolon is usually used when you're ending an expression. If you are trying to return something, you don't use a semicolon. There are other instances where you're not going to be using a semicolon. I think it's while you're using structs. There are, I'm pretty sure, enums as well. You don't use semicolon. We'll see what other things don't use semicolons, but majority of things are like you're creating a variable, you're going to use a semicolon because you want to end that expression before you begin another one. Okay, compilation and execution. So you just run a newly created program. So let's examine each step in the process. Before running a Rust program, you must compile it to the Rust compiler by entering rustc command and then passing it the name of the source file, like rustc main.rs. If you have a C or C++ background, you'll notice that this is similar to GCC or Clang. After compiling successfully, Rust outputs a binary executable. On Linux, Mac OS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. All right? And that's what I was doing before when I couldn't find the hello world. I was entering ls, which will show you what's in this hello world directory. So if you want to go back a little bit, we're going to do cd, 2 little dots. I'm back 1 directory. So I'm in projects directory now. And I can ls and you'll just see hello world because that's the only thing in that directory. You can keep going in. So we're going to do a cd into the hello world like that. And then I'm going to do an ls again. And now you're seeing all those, the main executable main.pdb and main.rs, which is the thing that we're working on right now. It's just something for you to understand about file directories. Interesting, I guess, to an extent. Okay, okay, so yeah, so we are seeing these files. You can see the main. And on Linux and macOS, you'll see 2 files. With PowerShell on Windows, you'll see 3 files that you use, seeing CMD. With CMD on Windows, you would enter the following. Okay, this shows the source code file with the .rs extension, the executable file main.exe on Windows, but main on all other platforms. Okay, and when using Windows, the file containing debugging information is in the PDB extension. From here, you run main or main.exe file like this. Okay, interesting. I did not know that. I don't really use Rust-C. So I didn't know that we just needed the PDB. I wonder what it stands for. Probably like debugging. Obviously, I think this part means debugging. I'm not gonna look it up right now. We're just gonna keep going. We're almost done with chapter 1. I think we're gonna stop at chapter 1 today and then follow up with chapter 2 later. Chapter 2 has a really big section on it, on creating a whole program. So it's actually really cool. You see programming in a guessing game. Okay. If you are more familiar with the dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is a ahead-of-time compiled language, meaning you can compile a program and give the executable to somebody, and then run it even without having Rust installed, which is literally so cool. Like what? If you give somebody a .rb, a .py, or .js file, they will need to have Ruby, Python, or JavaScript to implement that. For implementation installed, respectively. But in those languages, you need 1 command to compile and 1 to run the program. Everything is a trade-off in language design. So just compiling with Rust-C is fine for simple programs, but as your project grows, like we were talking about before, you'll manage all the options to make it easy to share your code. And next we're going to introduce Cargo Tool, which will help you write real-world Rust programs. And that's essentially what we use. We don't use Rust-C. We use Cargo when we're compiling and testing and doing all that fun stuff. All right. I'm just going to take this all out. Perfect. Okay. I think we're going to go back a little bit and probably create a different project within it. Yep, called Hello Cargo. So before we do anything, I'm going to read this out, of course, but before we do anything, do a cd space ... go back in a directory, because a project directory is essentially what encompasses what all these little projects are going to be in. So I hope you understand more of the file system and like how it's working. But if you need more in-depth explanation, there are plenty of videos on how file structure is within code. And it does get a little bit confusing, so I would suggest to go and research that yourself. Okay. Hello, Cargo. Cargo is Rust's build system and package manager. Most Rust stations use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built Hello World project within Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust projects, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. It is very easy, honestly. But the vast majority of projects use Cargo, or Rust projects use Cargo. The rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you need the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. And you can check. Let's see if I can check. Let's do, I don't know, maybe because we're in the project directory. It should be within your, what is it called, path. I'm pretty sure it's a global path. Oh, you can see it. I have Cargo 1.93.1. I'm not sure if that's updated or not. I just work here. Anyway, if you see the version number, you have it. If you see an error, such as command not found, look at the documentation for your method of installation to determine how to install Cargo separately. Especially if you're on Windows, I had this issue. And I know a lot of times you're just going to be troubleshooting a lot of issues when you're downloading new packages, which is learning. You're learning how to do things and how to troubleshoot new things, and it's a good thing because it's going to take you a very long time. It's going to be very frustrating. Look in your path. It's a percentage path percentage. I think it's called like global path or environment variable. My bad. Look in your environment variables on your Windows machine. I don't know anything about Mac. I do have a Linux machine, but I don't know if a lot of people use Linux like that, especially new beginners that are trying to learn on their own machine. Yeah, look in your environment variables, see if it's even there, because if it's not there, you need to add it. And you can use, Claude or ChatGPT to go and figure out how to add stuff. But this is really good troubleshooting too. So if you have any errors, don't see stuff, there's a problem and you need to go figure it out. All right. Okay, so let's create a new project using Cargo. And look how it differs from our original Hello World. So remember, we only have 3, well, if you're on Mac, you probably only have 2, but you have 3 files within your Hello World project, and we'll move to the projects folder. Actually, let me see if I can just open not this folder, this folder. Bro. No, what was it? Project. It was just projects. So you have so much stuff. Alright, and then we're just gonna select the projects folder. Do I have 2? Okay, no, I just have 1. Okay, so you can see our previous folder, our Hello World folder, is in the projects folder. You know what I'm saying? Now we're gonna create another folder within this folder. And make sure, because I just moved my folders. I just went back one directory. So make sure that you CD into that specific folder. Not the Hello World folder. We're going to CD into our cargo folder after we create it, okay? Alright, so let's create a new project using cargo and look how it differs from our original Hello World project. And then we'll navigate back to the project's directory or whatever you decide to store the code. Then on the operating system, run the following. Okay, so we've navigated back to our project directory. We're going to run cargo new hello cargo. Okay, so we have a new one called hello cargo, and it's got some different things. It's even got another file in it called source that has the main RS file. So we didn't even have to create a main RS file. Girl, get out of here. Anyway. Okay, so now you see that the first command creates a new directory in the project called Hello Cargo. We've named our project Hello Cargo, and Cargo creates its files in the directory of the same name. Yep. Go into Hello Cargo directory and list the files. You'll see Cargo has generated 2 files and 1 directory for us. Cargo.toml file, a source directory with the main RS file in it. It also has initialized a new Git repository along with a git ignore file. Git files won't be generated if you run cargo new within the existing Git repository. So you can override this behavior by using cargo new -svcs equals git. So we haven't talked about Git yet, but you will be using GitHub and Git commands, hopefully very soon. If you're not only already using it, if you don't already have a GitHub account, that would be a separate video. There are so many videos on how to create a GitHub account. I will show you how to create a repository and then upload your information from that repository, upload it from your local machine to the repository. Mistakes that I've made on the way of doing GitHub, it took me forever to figure it out. Honestly, I'm a very slow learner, and that's okay. I think it's okay to be a slow learner. That means you learn more in depth. You learn all your aspects of whatever it is. But so it has also initialized a new Git repository along Git ignore file. Now Git files will be generated. I think I already read that. Okay, open cargo.toml file. You're going to be using this file a lot, especially when you're using dependencies. That's the lovely word that we need. We need these packages, these dependencies. They're going to be very useful later on when you need to utilize those dependencies within your program. Okay. This file is the TOML file, or Tom's Obvious Minimal Language Format. I wonder who Tom is, which is Cargo's configuration format. The first line, package, is a section heading that indicates the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information. Cargo needs to compile your program. The next name, the version, the name, the version, the edition of Rust to use. We'll talk about the addition key in Appendix D. Oh, I forgot to go back to Appendix D. We'll go look at the appendix that I've never been in there before. The last line, dependencies, is the start of the section for you to list any of the project dependencies in Rust. The dependencies. In Rust, packages of code are referred to as crates. We don't need any other crates for this project, but we will in the first project in chapter 2. So we'll use the dependency sections then. So yes, so there's a game that we'll be creating in chapter 2, and I think that should be a whole separate video because I kind of really want to deep dive on creating a game. We might do a little twist on the game. I like to do little twists just to solidify some knowledge that we just learned, and sometimes even gain some new knowledge. You never know. Alright, so now open the source.mainrs file, and you see that your hello world is there. Cargo has generated a hello world program for you, just like the one we wrote in listing 1-1. So far, the differences between your project and the project Cargo generated are the Cargo placed the code in the source directory, and we have a cargo.toml configuration file at the top. We also have a git ignore. I don't think there was a git ignore in the last one. We can just check. Yeah, there was no git ignore. It's just a main.exe, main.rs, and the pdb. Okay, Cargo expects your source files to live inside the source directory. The top level project directory is just for README files. So license information, configuration files, and anything else that's not related to your code. All of the code that you would like to put in it will be in that source file, essentially. If you start a project that doesn't use Cargo, as we did in Hello World project, you can convert it to a project that does use Cargo. Move the project code into the source directory and then create an appropriate cargo.toml file. One easy way to get that cargo.toml file is to run cargo init, which initiates or cargo initiate, which will create it for you automatically. So you can convert, let's say you create another project and you want to convert it into a Cargo project. You can just convert it by creating a TOML file and then also initiating the project and also creating a source file. So, folder. Alright, we're almost done. So building and running a Cargo project. Now let's look at the difference between when we build and run Hello World project with Cargo. From our Hello World directory, build your project by entering the following command. So we're going to go back to our Hello World directory. I do a Control J to open up my terminal. I'm not there. So I'm going to cd into my Hello World project. I'm just going to tab. My nails are too long. I need to cut them. So now I'm in my tab. Now we're going to do a cargo build command to compile. Hello World. I'm supposed to be Hello Cargo. Okay, I'm going to cd back. Let's do change directory, Hello Cargo. My bad. And then we're going to do a cargo build. Oh, these nails are getting in the way. Look at it. It's doing something. Okay, it finished. This command creates an executable file in target debug hello cargo. So you can see right when I did that, this little target folder showed up. And look at that, it says debug. What's happening? Why is it being weird? Okay, anyway. It says target, which is the folder, debug. Look at all this stuff in here. Rust C info, JSON, hello cargo exe. They even got more stuff in these folders. I don't know what all this does. There's nothing in build. Tabs, examples, incremental. I'm not sure exactly what all of these folders do, but create a whole different folder, which is very nice. Okay, let's see what it says. You can run the executable from this command. Alright. If all goes well, hello world should print in the terminal. Did it print? I think we need to do a cargo run for it to print in the terminal, because we just compiled it essentially, and we didn't return anything. So if all goes well, hello world should print in the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level called cargo.lock, which we do have right here. This file keeps track of the exact versions of dependencies in your project. This project doesn't have any dependencies, so the file is a bit sparse. You won't ever need to change anything in this file manually. Cargo manages its contents for you, so don't ever go in there and change things up because you'll mess up your program. We just built a project with cargo build and ran it. Oh, I didn't run it. Was I supposed to? No, I didn't run it. Anyway, ran it with .target debug hello cargo. Oh, okay. But we can use cargo run to compile the code and then run the resultant executable all in one command. Let's go use it. Cargo look at that. Perfect. So we actually have the result of hello world in our terminal. We just built this project and blah, blah, blah. Alright, so we just ran cargo run. Now using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary so most developers use cargo run. I use cargo run, I use cargo build sometimes. Usually in the beginning of the project I'll build my project and then I'll use cargo run just to see. There's also cargo test. I don't know if they're going to talk about that. Cargo check. I think that's what it is. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles and doesn't produce an executable. Okay, so it was cargo check. It tests what's going on before it tries to compile it. And then it panics, like let's say you have some syntax issues and then it'll panic. Hopefully cargo check will... I've actually never used cargo check before, so I'm not sure if it's something people usually use, but maybe I should start using it. The more you know. Honestly, this is supposed to be helping me in the process as well. Although I'm a developer and I should know these things, sometimes you forget these things over time, and it's nice to go back and see what's in the book. Alright, so we do cargo provides a command to quickly check your code, which is cargo check. So let's do a cargo check. Cargo check. Alright, everything looking good. So why would you not want an executable? Often cargo check is much faster than cargo build because it skips the step of producing an executable. Oh, okay. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rustaceans run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use executable. So let's recap what we learned so far about cargo. we can create a new project using Cargo New. I think there's also Cargo Init. I don't know if it uses the same. I think it's like Cargo Init, and then you can put your project name, or you can do Cargo New project name. We can build a project using Cargo Build. We can build and run a project in one step using Cargo Run. I usually use Cargo Run. We can build a project without producing any binary to check for errors using Cargo Check. I'm going to start using Cargo Check now. Instead of saving the result of the build in the same directory as our code, Cargo stores it in the target/debug directory. It's actually very useful to know. An additional advantage of using Cargo is the commands are the same no matter which operating system you're working on. So at this point, we will no longer provide specific instructions for Linux and Mac OS versus Windows, because Windows has to be different. Building for release. When your project is finally ready for release, you can use Cargo build -- release to compile it. So let's try that. Yep. Now what did that create? Another release file. Look at this. Now let's see what it does. This command creates an executable to the target/release instead of target/debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles. One for development when you want to rebuild quickly and often, and another for building the final program where you give it to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code running If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark the executable in the target/release. I've never done that before. And this is like the quirks of like learning how to do new things. Like this may be chapter 1, but some of these things I've never done. And I've read this book, don't get me wrong, I've read it. But it's just different when you're reading it and you're also understanding and utilizing what you're reading. You know what I mean? Like you're doing the actions while you're reading. It's completely different. It's completely different. So I hope that you're also following along and doing this with me so that you understand as well. The best thing to do is to start doing the projects. With simple projects, Cargo doesn't provide a lot of value over just using Rust-C, but it will prove its worth as your programs become more intricate. Once programs grow into multiple files and need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of real tooling that you'll be using in the rest of your Rust career. In fact, to work on existing projects, you can use the following commands to check the code using Git. Change the project directory and build. So you do a git clone, and this would have your git clone is going to be your repository, okay? This is what you're creating on GitHub. You're creating your repo there, cloning it so that you can have it on your local machine, and then you can commit any changes to your new repository. You know what I mean? So you do a git clone and you're going to do a cargo build, and then you can also do like a git add period and then git commit, and you can put like a little comment in it, and then after git commit you push it off. So you do git push it off into GitHub, and it will be living there. It's like proof that you did something. Okay, so we're already off to a great start. I'm not gonna read all that. This is a great time to build a more substantial program that we use for reading, writing, Rust code. So in chapter 2, we're going to be building a guessing game, and that's going to be a fun one. I think I had built a guessing game. Maybe it was this one. I can see if I can go and find it, but it's somewhere in my folder in my documentation. So I hope you enjoy this video. This is the first time I've ever done one of these videos. I didn't know this was so long, but I love long form content. So if you want to keep following along, I'm going to do chapter 2, and so on and so forth. I think there's about 21 chapters. We can check. Let's see. Yes, 21 chapters, and the last one is building a multi-threaded web server. So I'm so excited to get to that one. Let's become really freaking good at coding, and obviously this is my journey to going to a Solana developer or Web3 developer in the end, but foundation is key. Having solid foundation is so key, so let's go through it together. All right, bye.